All right, what happens when we square a binomial? Well, a binomial could have two forms. It could be formed by addition, or it could be formed by subtraction. So what does this mean? A plus b all squared. That's a plus b times a plus b. So that'll be a times a plus a times b plus b times a plus b times b. Right, and then since multiplication is commutative, these are both basically the same. So we'll have a squared plus 2 times ab plus b squared. What about a minus b squared? Again, that's a minus b times another a minus b. So that'll be a squared minus ab minus ba. Negative b times negative b will be positive b squared. So this will be a squared minus 2ab plus b squared. All right, why is this useful? Well, if we know we have one of these on our hands, we can factor it pretty easily. How can we tell we have one of these? Well, if we have a trinomial in which two of the terms are in fact perfect squares, we should try to factor it as a perfect square and see if it works. So, for example, suppose we encounter this polynomial. We notice that the first term is a perfect square. What is it? It's 2 times x squared, all squared, right? 2x squared times another 2x squared will give me 4x to the fourth. And the last term is a perfect square. 3y all squared, right? 3y times another 3y will give me 9y squared. I see that this is subtraction. So I wonder, can I factor this as 2x squared minus 3y all squared? How should I find out? Right, multiply this out and see if it works. 2x squared times 2x squared is 4x to the fourth. 2x squared times negative 3y is negative 6x squared y. Negative 3y times 2x squared is negative 6x squared y. Negative 3y times negative 3y is positive 9y squared. Combining these two like terms in the middle? Yes. This does factor as a perfect square. Now, is this easier than using other procedures than I might have? Yeah, it is. Sometimes it doesn't work. Maybe I have 4x squared plus 37xy plus 9y squared. Right, I notice that these two terms are perfect squares. This is 2x all squared. This is 9y all squared. But if I take, notice this is addition. If I take 2x plus 3y, 2x plus 3y, and square it, right, that's 2x plus 3y times 2x plus 3y. That'll be 4x squared plus 6xy plus another 6xy plus 9y squared. And notice 6xy plus 6xy doesn't add up to 37. I'm going to give you one of these to try. Is this polynomial a perfect square? If it is, factor it. Pause the video and try this now. All right. Well, the first term is a perfect square, right? It's 2x squared y, all squared. The last term is a perfect square. It's 7z cubed, all squared. So, and I also notice that this is subtraction. So if this is a perfect square, it's going to have to be 2x squared y minus 7z cubed, all squared. Multiply this out. I'll get 4x to the fourth y squared minus 14x squared y z cubed plus 49 z to the sixth. And I see that when I combine like terms, I do indeed get this middle term that I wanted. So yes, it is 2x squared y minus 7z cubed squared.